Okay, here's a question for you. What's the one thing that stops a 1,000-pound EV battery from becoming, well, a huge fire risk? Today, we're going to dive deep into the engineering behind the EV's hidden brain, the battery management system. I mean, think about it. Every single electric car out there is basically carrying a massive, high-energy battery pack. You could almost call it a controlled chemical reaction on wheels. So what critical piece of electronic intelligence is running behind the scenes, making sure all of that power doesn't go spectacularly wrong? Well, the answer is this. This kind of unassuming piece of hardware right here, it's called the Battery Management System, or BMS for short. And honestly, it's the real unsung hero that makes high-performance EVs not just possible, but safe to park in your garage.
So to really get why this thing is so important, let's break down what a battery management system actually is from an engineering standpoint.
You can think of a BMS as the central nervous system for the entire battery pack. It's an embedded electronic system, and it really has one core mission: to precisely monitor, control, and protect the hundreds, sometimes thousands, of individual lithium-ion cells that make up that giant battery.
And this brain is juggling four primary jobs all at once. First and foremost, it ensures safe operation, keeping the battery inside its very strict happy place. Second, it's constantly working to optimize the car's performance. Third, it's trying to extend the battery's overall lifespan, to protect your investment. And finally, it provides a constant stream of vital data and diagnostics. So yeah, it's both a guardian and an optimizer.
But why is this guardian so absolutely necessary? Well, it's because lithium-ion batteries, for all their incredible energy density, are, let's just say, chemically volatile. They are incredibly sensitive to their operating conditions. And just look at how narrow that optimal window is. Lithium-ion cells really perform their best between about 15 and 40 degrees Celsius. If you go too far outside that range, either too hot or too cold, you're going to risk poor performance, faster aging, or something much, much worse. And this is that something worse. It's a terrifying chain reaction called thermal runaway. See, if just one single cell overheats, and this can start happening around 85 degrees Celsius, a protective layer inside it starts to break down. This kicks off a self-sustaining chemical reaction that generates even more heat, which causes flammable gases to vent and pressure to build until you get a catastrophic failure. This domino effect is the exact scenario the BMS is designed to prevent.
So, how does the BMS actually tame this fire within? Well, it really boils down to three fundamental jobs that it performs relentlessly, every single millisecond the car is on: sensing, protecting, and balancing.
First up is sensing. You got to think of it as a network of super sensitive nerves spread all over the battery. The BMS is constantly sensing the voltage of every single cell, the total current flowing into or out of the pack, and the temperature at dozens of different points, using little sensors called thermistors.
And then it uses all that data to act as a protector. If it senses the voltage on a cell getting too high while you're charging or too low while you're driving, it steps in. If it detects a dangerous spike in current or a short circuit, it can trigger these huge switches, called contactors, to physically cut the battery off from the rest of the car in microseconds. And if those temperatures climb too high, it'll crank up the cooling system, or in a worst-case scenario, just shut everything down.
But here's the thing. While sensing and protecting are reactive, they respond to problems, the BMS has a much more sophisticated, predictive side to it. It's not just sitting there watching for danger, it's constantly running complex algorithms to calculate the battery's present and future capabilities. This starts with something you've definitely seen, the state of charge, or SOC. That's your fuel gauge. But it isn't a simple measurement. No, it's calculated using some pretty clever algorithms that track the current going in and out and combine that with voltage and temperature data, all to give you that accurate percentage you see on your dashboard. And building on that, we have the state of health, or SOH. You can think of this as the battery's long-term report card. It keeps track of degradation by comparing the battery's maximum capacity today to what it was when it was brand new. A new battery is at 100% SOH. As it ages, that number drops, giving you a really crucial idea of its remaining useful life. Okay, but here's another layer of complexity for you. An EV battery is basically an army of thousands of individual cells working together.
And because of tiny differences from manufacturing and even just different temperatures across the pack, some cells will always charge and discharge a little bit faster than others. Over time, this imbalance can really limit the pack's performance and can even become a safety risk.
So, the BMS solves this with something called cell balancing. Now, there are two main ways to do it. Passive balancing is the simple, cheap method. It just uses tiny resistors to basically burn off excess energy as heat from the most charged cells, which lets the others catch up. Then you have active balancing, which is way more efficient. It acts like a little energy shuttle, using capacitors or inductors to move energy from the fullest cells to the emptiest ones. Almost nothing is wasted.
So we've seen what the BMS does deep inside the pack. But its job definitely doesn't stop there. It's the central communication hub that connects the battery with the entire car. This diagram gives us a great look at that network. What we're seeing here is a classic centralized setup. Right in the middle, you've got the MCU, the microcontroller. That's the main brain. It connects down to all the cell monitoring units. Now, some other cars use different designs, maybe with more intelligence spread out, but in any case, this main unit connects outwards, controlling those big contactor switches, and most importantly, talking to the rest of the car over the vehicle's network, which is usually called the CAN bus.
And that communication network is extensive. The BMS is in a constant conversation with the main vehicle control unit, telling it exactly how much power it's safe to use. It negotiates with the charger to control charging speed based on the battery's temperature and voltage. It commands the liquid cooling and heating systems to keep the battery in that perfect temperature window. All of this critical data has to be communicated with absolute reliability, which is why it's all governed by strict safety standards like ISO 26262.
And of course, this technology is not standing still, not by a long shot. The demand for more range, faster charging, and even greater safety is pushing engineers to make this hidden brain smarter and smarter every year. The next generation of BMS is already here. We're starting to see AI and cloud-connected digital twins that can predict battery health with unbelievable accuracy. There's also wireless BMS technology that gets rid of all the complex wiring inside the pack, making them simpler, lighter, and more reliable. And getting rid of those wires is a huge deal. It's what enables crazy new designs like cell-to-pack and structural battery packs, where the battery itself becomes part of the car's frame. So when you boil it all down, it really comes down to this. The BMS is the nerve center. It's what transforms a box of raw, volatile chemical cells into the sophisticated, safe, and durable power source that a modern EV absolutely has to have. It truly is the silent guardian, constantly running in the background, sensing, protecting, and optimizing everything. And as we keep pushing the limits of battery technology, its job as the intelligent enabler of our electric future is only going to get more and more critical.